Good morning.
Morning.
Hi. Morning, Ananda.
I didn't realize that the link got changed with a SIG to tag renaming.
So this is my first time, and I was looking for so I had this calendar. I had the entry in my calendar for every week, and finally I managed to book some time to attend, but I didn't find the password, and I had to look the Slack, and it was not in the invitation, but I had to look at the header of the Slack to find out. It's okay, the password there. Not sure, yeah, it was a bit hard to find.
Maybe it's the same password for the variety of the CNCF meetings. Okay. So people kind of know about it after doing it several times.
Yeah, I'm a noob in the CNCF world, from a meeting perspective. So yeah.
Welcome. Where are you based off?
I'm actually in Germany.
Nice.
Yeah. Also in the agenda, there is the June 1st entry. I think today is June 3rd. So is this the entry for today, or?
Oh, yeah, that's my fault.
So sorry for nitpicking on these small things.
Yeah, actually, there wasn't a item on the agenda today, so I just copied the one from the July.
Are we all waiting for Ricardo?
I think so.
I'm checking with Amy if Ricardo is around. He didn't join the last TOC meeting, so I'm not sure if he's on this week. Let's give it 5 more minutes.
By the way, was there a reason for renaming like SIG to tag? I'm just a curious.
Good question. Yeah, so there was a bit of a confusion. What is between CNCF SIGs and Kubernetes SIGs, and like an overlap. So we decided to rename it to avoid this confusion.
Thanks for lighting me up.
Kevin, I see that your item is on the agenda, right? You're supposed to do the presentation.
Yeah, I just realized I didn't make it public, so I'm trying to make the document public.
Oh, you mean the slides?
Yeah.
Okay. So I'm gonna copy paste the link to the minutes and agenda to the chat. So for everybody who's on the call, please add yourself to the list of attendees. Okay, I think like if Ricardo doesn't join, you can just go ahead with the presentation.
Okay. So shall I start?
Sure.
All right. Let me share my screen. All right. Can you see my screen?
Yes.
Okay, so I just want to introduce a new project. We actually opened it in late April, and yeah. Also, we have actually had a short presentation on the KubeCon EU, but I would like to give more details. And also, if any of you have any questions, I think this is a good chance to ask, and I can answer. So,
Kevin, do you mind if I start recording the meeting? I didn't.
yeah, sure.
Okay, just do it.
To me, it's actually showing it's already recording. But
Oh, it's already recording. Okay, cool.
Yeah, I think it's automatically.
Maybe it's automatic, yeah.
Mm-hmm. Okay, so I think we all already know about that. The multi-cloud is definitely the one of the most important enterprise cloud strategies. So I will not spend too much time on this page. So I just want to say that today the multi-cloud, especially when adopting the cloud native technologies, are still very challenging. So especially to me, there are a couple of aspects. For example, Kubernetes make a very good situation that everybody can use the standard Kubernetes cluster in any cloud, but it may result in too many clusters, especially today we don't have a very kind of standard cluster lifecycle management, and also we may result in too many API servers or too many API endpoints, and also because of the too many clusters, our workload may be fragmented in the different clusters, and also we may already know that the multi-cluster service discovery and the traffic routing is challenging, and another thing is that when we try to deploy a same application to multiple clusters, we need to manually manage the configuration customization per cluster. That's kind of also very challenging. And also today the resource allocation, the resource scheduling is limited to the boundary of the single cluster. And also we, especially a lot of end users, I reached in the months past, they are facing challenges about the clusters availability. This is not just about the worker nodes, but also some of them may use like of the SAN as the storage backend. If any if any bandwidth change or any quality of QoS change about the storage system, the whole cluster may become unavailable. And also the application auto-scale, horizontal auto-scaling is limited by the clusters. And another thing is that even though we have standard Kubernetes and also the cloud-native tech software stack today in different cloud, but it's kind of we have the data gravity and also the development deployment gravity. So it's kind of still very challenging to migrate the application instance and also the data between the clouds. So that's why we working on the trying to make the multi-cloud thing simple. So the K-Armada project, actually we have some background in the early days working on the Kubernetes Federation, but we realized that it's not just about the Federation itself, because the Federation is more likely just focusing on the application management between the Kubernetes clusters. And another thing we realized that actually the Kubernetes native API compatibility is very important. People today are familiar with Kubernetes, the native APIs, especially the core APIs, but still not quite willing to learn too many the extended APIs, like a lot of new CRDs. And another thing is that we want to actually to see an open and vendor neutral project in the ecosystem that trying to bring the best functionality as well as the openness of the community to the end users. So that's why we started working on the K-Armada project, and also for the multi-cluster application management, we are trying to make it simple with a set of built-in policies to enforce the like the active or remote disaster recovery model that are quite well known today in a lot of application deployment. And also, we think that to simplify the multi-cluster scheduling, the multi-cluster resource allocation, we definitely need a lot of advanced scheduling policies across clusters. And also, another thing is that like in the old days when we are working on the Kubernetes Federation project, a lot of clusters may locate in a private network, or even today we can imagine there will be more and more clusters on the edge. So the network is not the same with those clusters in the cloud. So if we can provide the centralized management for the different location of the clusters, that would be very helpful. So actually, the K-Armada project, we are the architecture is very simple. So you can see that we have its own API server here. But today, actually, we are just using the Kubernetes API server binary because we need to expose the Kubernetes native APIs, and also a set of extended CRDs. The policy APIs provided by Kamada are installed as CRDs. And also we have the K-Armada scheduler to deal with the multi-cluster scheduling. And also we have a set of workload controller to deal with the how to automatically dispatch the native Kubernetes resources to the different clusters. For the synchronization between the K-Armada control plane and the member clusters, we actually support multiple mode. So one is to use the centralized controller. This is helpful when people don't want to use too much of the resources in the member cluster. And also this is kind of the very clear mode we did in the Kubernetes Federation v1 and also the KubeFed. But for some clusters, they may locate in the private network or in the private cloud. We use the K-Armada agent to synchronize from the updates from the control plane, and also for the clusters on the edge, we are relying the KubeEdge to deal with the low quality network between cloud and edge. So the execution space here is kind of a special folder isolation for different clusters. It's actually a special kind of namespace. So here, this diagram is kind of the main API workflow about the K-Armada project, how it spread the resources to different clusters. We actually are reusing a lot of basic concepts from the day we bring in the Kubernetes Federation project. So the application here, we just say them as the name of them as the resource template. Here, actually, user can just use the Kubernetes native API definition. That means you can directly bring a vanilla Kubernetes YAML file and submit it to the K-Armada API server. So actually, there are different ways to use a K-Armada. So if you have a lot of common applications that need to spread it to the multiple clusters, or spread to multiple cloud environments, you can set up the propagation policy first, and also the override policy first. Override policy is the customization for the applications for the different set of clusters, and the propagation policy here is kind of a multi-scheduler scheduling configuration for each kind of resource or workload. So the policy controller here is to find the best match propagation policy, and it will create an internal resource to make it go through the whole API workflow. And also the k-armada scheduler will fill up the binding clusters to tell the system that which set of clusters this resource need to be propagated to. And also the override API, actually we even though the concept is the same with the one in the Federation, Kubernetes Federation, actually we make it a standalone API here, so it can filter what kind of resource I will apply to, and the certain override policy will only affect the resource going to some specific clusters. So the work API is actually a kind of concept recently under discussion in the Kubernetes multi-cluster SIG. It's kind of an internal API to deal with the status synchronization between the control plane and the real resource in the member cluster. And the last step, we can just use the centralized controller, or rely on the agent in the member cluster to synchronize between the status between control plane and the member cluster. And then let me just explain how the APIs look like in the k-armada project. So for example, we have some application that we want, they always need to be deployed into 3 zones. So we, when the system set up, we can just create a reusable propagation policy config to filter all the deployments that has the label HA mode and the value is multi-zone replication. And with the placement section, we can configure the spread constraint. And this is actually trying to dynamically group all the member clusters into different groups. So we can say I want to group all the clusters by zones, and I want to exactly limit my application spread to 3 zones, so we can get 3-zone replication of the all the deployment. So on the right, you can find out actually it's exactly a vanilla Kubernetes API YAML. You can just apply to the k-armada API server. And so these are the a little bit more details about the propagation policy. So actually we are, because we want to bring the experience that users can just bring the vanilla Kubernetes APIs, they interact with a single cluster day to day. So we actually split the multi-cluster scheduling configuration into a standalone API. That's the propagation API. So we use the resource selector to match the resources. That means what kind of the Kubernetes resources we are going to apply to. And actually, so this is kind of very common selector that to filter with the API version and the kind. So we also support match any kind of CRDs as well. And the users can also use indicate with the exact name to just make it apply to a specific resource, or they can use resource label selector to match a set of API objects. And also in the placement section, we have the cluster affinity rules. Users can just either iterate the cluster names, enumerate the cluster names they preferred for scheduling the applications, the resources, or they can just use label selectors to select a set of clusters. And also, in some case, users may have some clusters for special use case. For example, they have a lot of GPU resources in that cluster, so they just want the AI workloads or the machine learning workloads go into that cluster. So we bring the taint toleration concept to the cluster and the propagation policy level. So any resources propagated by the specific policy that has the toleration, then it can go to go on to the certain cluster that has the corresponding taints. Otherwise, they cannot go to there. It's kind of very similar mechanism comparing to the pod toleration and the node taints. And also the spread constraint, like I said in the example, it's actually trying to dynamically group the clusters by the by different aspects. Here in the example is spread by cloud by the field, a built-in field, but we also support spread by labels. And the users can set a range of the groups or just set indicate a exact number of groups. So for the override policy, we also think that because some of the clusters, for example, they may locate in the same cloud or are provided by a same provider. So they may have some common setup. For example, today, a lot of users would prefer internal container image downloading to save the bandwidth and also save the cost. So in that case, when a certain application go into different clusters in the different cloud, the container image, especially the container image prefix, need to be replaced so that the Kubernetes can download image from the internal, the in-cloud container registry. So, and also another example is that different cluster may have a certain background of the container storage setup. So the storage class may be different. So we definitely want to simplify the storage class customization when the application go into that cluster. That's why we also make the override policy a standalone API, and we again we use a resource selector to restrict what kind of resource or resource types this override policy would apply to, and also we have the filter to limit the target clusters, that means this override policy will only take effect when the workloads or the resources go into a certain set of cluster. And for the overriders here, actually, we are trying to bring a multiple plugin mechanism. So the basic one is the plain text overrider. It's this is very similar to what we have in the Kubernetes Federation or KubeFed. So just find a certain path of the field and replace with value or add a value or remove a value. But in the longer term, for example, the image. So we know that some of the container image, for example, those are in the hosted in Docker Hub. They actually don't have the prefix. But when going to a certain cloud, we need to add the prefix. So image overrider is to it will kind of is a handy tool to detect the different part of the content in the container image address, and people can just replace with a certain part of it. And also in the longer term, we want to add more the override plugins. So for the member cluster management, this one may be quite common. So actually in some end user cases, we found out that they may have an infrastructure team to manage a very large pool of clusters. But when they are serving to the business teams, the different teams, they want to know something about the underlying resource pool. For example, they want to know how many clusters they can run their applications, and also they want to query the resource usage and the availability, and also the cluster location. So they can customize, for example, the HA policy or the resource setup or the number of the replicas set up when they are running the applications to the different clusters. So that's why here we actually make it the cluster the cluster access token into a secret, but just keep some of the very basic information in the cluster API. So the infra team can just open access of the member cluster API to all the business teams, and they can query by themselves. So one of the things new here we think is very helpful is that today we can see a lot of users have the multiple provider. The clusters come from multiple providers, and they may have their definition of regions or zones. So we make this the properties as the fields in the member cluster API spec, and also we are collecting the Kubernetes Federation and also the API groups enabled in the cluster directly in the cluster API status. So we think that's very useful for especially the administrators to debug when or why their application cannot go on to a certain clusters. Maybe because the application they are using some specific new API that the oldest cluster doesn't support. And also for the node summary, we are actually trying to collect and summarize the resource usage, and also trying to help give an overview of if the cluster is healthy enough or not, so we can add more advanced scheduling policy on that, so we can schedule more applications to idle cluster or to a healthy cluster. So actually, for the whole project, we want to provide a turnkey solution to the end users, because in the past development, we found that building blocks are not just not enough for the end users. If too many customization on top of the building blocks, they may result in no standard. So that's why we kind of divided the capabilities into different modules and trying to make them pluggable. So when the end users adopting the project, the technology, they can just enable the part they need, or they enable the part that would be helpful to them. So in the middle layer, the core pieces, actually, so what Federation and the KubeFed did in early days is that they are focusing on the workload management. And also the cluster registry, there's was an sub-project in the multi-cluster Kubernetes multi-cluster SIG, but it's kind of out of life cycle, I think. Another thing is that we actually want to provide a unified API endpoint, or it's kind of a aggregated Kubernetes API endpoint. Remember, we in the challenge we said that if people have too many clusters, switching between the kubeconfig context is challenging, because you may forget which cluster you are interacting with, and also it's also challenging to do the API auditing, and also the like the access configuration. So if we have a aggregated API endpoint, the unified API endpoint, we can just enforce the authentication, the authorization, and also the API audit at the same point. And also for the different clusters, even though the member cluster may locate in a private network or or on the edge, we can the users no need to be aware about the details. They just they can just interact with the single access point of the Kubernetes API. So underlying, actually, we're just trying to develop with the Kubernetes core, and also these are actually what we already have today in the community. And on the top, we think there are kind of advanced layer, especially the multi-cluster scheduling. Recently, we are also adding a lot of advanced feature. For example, dispatch and divide the replica of a deployment according to the cluster resource availability, or according to the different weight of the cluster, or different weight of the cloud. And also for the multi-cluster scheduling, this one is also very challenging, because if one of the cluster become a lack of resource, so one option is that we scale up that cluster, and another option is that we can just spin up a new cluster. So this challenge becomes more obvious when people have their clusters in different the different cloud providers, because the pricing model and also the underlying resource availability model may be different. So we want to when the system making decision about whether scaling the existing cluster or spinning a new cluster, they can get to know more information about the current the application location and also the resource information, and make a better decision. And also we know that today the policy management and the config management are actually kind of a lot of repeated work if we just set up one by one on the different member clusters. So if we can have a universal management, that would be very easy. And also, actually, to adopt the whole system, the things like multi-cluster monitoring, logging, and also the networking stuff are definitely needed. But we have seen a lot of other open source projects already working on that. So we will just integrate with them. Okay, so so this project actually we started in last year, and in Q1 and the Q2 we already make a lot of implemented a lot of basic functionalities. So currently the K-Armada is able to dispatch or spread the applications with defined by native Kubernetes APIs to multiple clusters. And we can aggregate the application status to the K-Armada control plan, so users don't need to interact with the underlying cluster to check out the details of the multi-cluster application. And also, we already implemented some of the multi-cluster scheduling policy, including the HA policy, the cluster affinity, and the taint toleration at the cluster level. And also we have implemented the different synchronization mode between the control plane and the memory clusters. In the next half year, we are going to integrate with the like the multi-cluster service API standard discussed in the Kubernetes multi-cluster SIG, and also provide the integration with the other projects to provide the multi-cluster networking and the multi-cluster traffic routing. And also we will add more functionalities about the resource management, like the resource rebalancing and the horizontal auto-scaling of the applications. And we are expecting to have a kind of the 1.0 late this year to have all the functionality part on our landscape implemented at least the alpha status. Okay, so this project, we think the end users are definitely very important. So when we started working on this project, we invited a lot of end users in China to also share their experience on managing the multi-cluster the resources and the applications. So these are the founding members, and also in the recent weeks, there are a lot of more end users joining in this project. So you can find out that, for example, we have the end users from the financial industry. The ICBC is the, if I remember correctly, it's the world's largest bank. And also SPD Bank is already an end user member in the CNCF. And also the Xiaohongshu and the VIP Kid, they are the internet industry end users. The VIP Kid is an online training company. And also we have the end users from the automotive and the manufacturing industry. So actually we are targeting on make the Keyamada an open project. So that's why I'm also presenting this project to the TAG. Actually, we are trying, we have planned to donate this project to CNCF. So for the alignment with CNCF, we think that the whole project is targeting on building an extensible and open architecture based on Kubernetes, and especially the most important API the users interact with the system, we think is the Kubernetes vanilla APIs. And also for the whole scope of this project, we definitely need to integrate with a lot of CNCF project. And also we are looking for more engagement with more project to have better and work on more the innovations. And also because it's kind of a continual work of the multi-cluster work, so I also would like to explain the relationship with the Kubernetes multi-cluster SIG today. So actually we have a long experience working on the Kubernetes Federation project. We are the contributor of Federation V1 and the V2, but today actually like I highlighted in the diagram, KubeFed is kind of a smaller scope in the software stack, and we think that it need to be a standalone project on the CNCF because we have a wider scope to do, and we are interacting with a lot of end users to collaborate together. And also we are not reinventing the whole thing. We inherited a lot of concepts of the we did in the Kubernetes Federation V1 and V2, and also today we integrated, for example, the work API from the multi-cluster SIG already integrated, and we are working on integrate with the cluster API to bring the integration with different cloud providers or on different service providers, and also the multi-cluster service we are going to integrate as well. Okay, so here are the resources about this project. So we, as an open source project, the Keyamada is still very young. But we are keen of the future. So especially even though it's just opened in late April, we have got more than 1,000 GitHub starts, and also there is some discussion in the on the Hacker News. So we think that. And we think that we may bring something useful to the end users. Okay, that's all about my presentation. Any questions?
Thank you for the great presentation, Kevin. I have a couple of questions. So the first one is networking across the clusters. So let's say I have a namespace and I have multiple deployments in this namespace. Will the scheduler, like, if the scheduler places these deployments in different clusters, how is the networking going to work?
You mean how the control plane sync with the member clusters, or like the pod network?
pod network, pod to pod. Like if two my deployments need to talk to each other and they're located in different clusters. How does it?
So yeah, so the pod network. So we will not implement the in the K-Armada project itself. We prefer to integrate with projects like the Submariner, and also we are recently also taking a look at the Cube OVN. It has some functionality to deal with the multi-cluster pod network thing. We prefer to integrate with such kind of CNCF projects.
Thank you. That makes sense. And let's say my deployments use secrets. How do you like these deployments exist in multiple clusters? How does the secret sync works in this case?
Oh yeah. So actually, in this the propagation policy here, like, so actually we can have multiple resources selectors here. So with this, the propagation policy, actually we can spread anything besides deployment and also the secrets and the config maps. We can all spread them with the propagation policy. And also, actually, we have a field here. This one is not yet implemented, but we it's kind of showing our idea. We want to automatically detect the dependency. For example, if we referred some config map or secret, we want the K-Armada automatically also dispatch the secret to the underlying cluster. So one restriction is that the namespace between the control plane and all the member clusters need to be same. So it means that if we create, for example, namespace 1 in the control plane, all the underlying member clusters will have the same namespace.
Got it. Thank you.
Yeah, I have a follow-up questions on Elena's question, and I have a couple of others. So the follow-up question is, are you allowing, so the model is that you're interacting with one cluster, right? You wanna make sure that you're interfacing with one cluster, but at the same time, do you also allow others to interact to clusters directly? And how do you manage that kind of like desynchronization? Because now you're interacting, someone is interacting with the virtual cluster, and people are directly interacting with the children clusters at the same time. How do you handle that?
Yeah, so actually for all the resources, so for example here, this one, the deployment is a user input. So when we synchronize the deployment to the underlying clusters, we will add an extra label to mark that resource is kind of managed by the K-Armada. And when we doing the list watch from the member clusters, no matter it's the list watch from the execution controller to the cluster or from the agent to the cluster, we will add the filter, add the label selector to make it watch only the K-Armada managed resources. So even though users are still directly interacting with the underlying clusters, it's okay. The only challenging thing is that if, for example, they create a they try to make the, for example, some namespace reserved for the underlying cluster, but another people create a same a namespace with same name from the control plane that may eventually become the same cluster. Otherwise, we think in the most of the case, it's still easy to understand for the end users.
Cool. Yeah. I had another question, which is, how do you handle you see, I've seen the API endpoint, but how do you like rotate, create, or ingest? Like you represent the cluster, you need the kube config to these children cluster. How do you represent that? and how do you make sure it's authenticated, authorized, and the certificates are rotated and so on for these children clusters?
Sorry, I didn't get the question.
Yeah, so you have a cluster resource, right? That cluster resource represents that a child, one cluster. I don't know how you name it, if it has a different name than the normal cluster, but I'm calling it child now. How do you discover that, and do you have to manually update the kubeconfig for each cluster if it goes stale, or if the certificates are expired, or how do you synchronize the state of authentication, authorization, and access in general between the
yeah, so currently for the existing implementation, people need to manually join the clusters to the KMRDA, but in the longer term, we want to make KMRDA able to spin up the new cluster from the cloud provider. And for the existing provider, existing clusters, the first time joining, the user need to bring a kube config or a token to able to make KMRDA able to interact with that cluster. After that, the KMRDA will automatically generate the its own the service account and config its own only the RBAC that for example the access they need, and they will keep interacting with you with that service account and the token. And also we will definitely bring the automatic certificate rotation to make KMRDA always able to interact with the member clusters.
Thank you. Yeah, I'm gonna wait and see if anyone has other questions, and then maybe I'll ask if there's time at the end.
I have a question. This is Diane. You said that in the future you'll be incorporating Prometheus. Is that correct? Or does it?
Yeah.
So now if someone wants to use Prometheus, they use it individually on each of the child clusters. I'm going to use that terminology too. Is that the case? And in the future, do you see the way to visualize all these clusters possibly through Prometheus? Or how do you think you'll be able to visualize the entire tree of clusters?
Yeah, so actually we are not trying to visualize everything. So like for Prometheus, we think that just directly use Prometheus in the underlying cluster, and we can rely on, for example, we can use the Prometheus Federation, or we can use Thanos to collect the informations to the control plane. But one thing we want to bring kind of a vanilla experience, same as the vanilla single cluster, is that we want to make the Helm chart support. So people because in the day when we are working on the KubeFed, a lot of people were stopped because of the incompatible APIs. So say if you have some Helm charts already today, you cannot directly apply it to a KubeFed cluster because the APIs are incompatible. So we want users able to just execute the Helm commands with the KMRDA API server. So that's why we made the propagation policy, the override policy, standalone API and reusable. So if they have common setups, they just set up at the first time, and then the day-to-day application deployment update, they can have the most similar experience when they are using Helm chart with the single cluster.
Okay. The visualizations will be on a per child basis, it sounds like. The Prometheus visualization of the clusters.
Mhm.
Okay. Thank you.
So any other questions?
Okay, maybe I'll ask one last question. How do you plan to, because you mentioned you have a ITCD, how do you plan to scale that out? You have many, taking care of multiple resources, and I'm not like there are probably scale limitations that doesn't apply to your model here. And is different. How do you
Yeah,
plan?
actually for the longer term, that's why we named this API server to K-Yamada API server. Even though today we are just taking the Kubernetes API server binary or the image to deploy it, but for the longer term, for example, the control plan higher availability itself. If someone want the control plan be higher available across regions, we definitely need to hook the API server between the API server between API server and the HCD. But in the short term, for example, if people just want to make the control plan running on the multiple zones, it's still okay to use etcd. But if people want the control plan spread across the regions, we may need to rely on other the database or metadata storage technology. We want to collect more feedback from the community first and then make the decision. And actually, another thing I want to add is that so today, actually, even we are providing the Kubernetes API native APIs, but people can still not query everything. For example, people created a deployment from the K-Yamada control plan, but when it go into the underlying member clusters, we're sending the deployment to the member clusters. We only divide the number of the replicas. Then in the member cluster, the pod is generated in the member cluster, and with no labels of the added by the K-Yamada, so people may not directly get the pod information today in the K-Yamada API server. But for longer term, with the the aggregated API endpoint, we are also investigating maybe, for example, add some the graphic storage to store the whole things we collected from the member clusters and provide advanced searching functionalities to the end users. Then with that implemented, users definitely no longer need to access to the underlying member cluster. They can do anything from the K-Yamada control plan. That's the longer term plan.
Thank you.
Thank you, Kevin.
Thank you for listening.
Yeah. Looking forward to learning more about the project.
Same, it was a first great session for me in a CNCF meeting. I really liked your presentation. Thank you.
Yeah, thank you.
So I'm going to stop sharing.
Yeah, the presentation is recorded, so we can reference it. You've mentioned that you're planning to submit your application for CNCF inclusion, right?
Yeah.
Should be referenced there.
I think the latest review is this month, right?
That's right. It's going to be on June 22nd.
Yeah, I will apply before that.
Awesome. Cool. I hope everybody has a good day or night.
Thank you, everyone.
Bye.
Thank you. Bye.
Thank you. Bye.